My topic is parallel database query parallelism. First of all, the introduction part. What are the parallel machines? Parallel machines are parallel machines are becoming very quite common and affordable. Then the prices of the microprocessors, memories, disks, and have dropped sharply, and the databases so that the databases are going largely or increasingly in numbers. Then the large volumes of transactions are collected or done and stored for the later analysis. And the multimedia objects like images are stored in the databases. And the large-scale parallel databases are used for storing the large volumes of data, then processing time-consuming decision support queries, and it provides a high throughput for the transaction processing. Then the parallelism in databases. Then the data can be partitioned or across the multiple disks for the input-output parallel processing. Then the relational operations such as sorting, join, aggregations can be executed in the parallel in the databases. And the data can be partitioned, and each processor can work independently on its own partition. Then the queries are expressed in a high-level language such as SQL, and they are translated to the relational algebra. The different queries can be run in a parallel with each other. That the concurrency control takes care of the conflicts. The databases naturally lend themselves to the parallelism. This is the architecture of a parallel database. It consists of the four parts. First one is the shared memory, the second one is the shared disk, and the shared nothing and hierarchical. The shared memory, it is the processors have a common sharing memory. The shared disk, the processors share a common disk. The shared nothing, that the processors share neither a common memory nor a common disk. And then hierarchical hybrid of the above architectures. That is, hybrid means it is a mix of the shared memory, shared disk, shared nothing. The typical database query types. First one is a sequential scanning, point query, and range query. And what is the inter-query parallelism? The queries transactions execute in a parallel with one another. That increase the throughput. The intra-query parallelism. It is the execution of a single query in a parallel on the multiple processors and on the multiple disks. It speeds up the long-running queries. There are the two forms of the intra-query parallelism. First one is the intra-operation parallelism, and second one is the inter-operation parallelism. Then in the intra-operation parallelism, it executes the individual operation in the parallel, an individual query in a parallel, and in the inter-operation parallelism, it executes the different operations or the different queries in a parallel. It doesn't execute the query simultaneously in the parallel. Then parallel processing of relational operations. Then the parallel algorithms we are assuming are the read-only queries and having the shared nothing architecture. We are giving the n number of processors and n number of disks starting from processors starting from P0 to Pn-1 and the disk starting from D0 to Dn-1, where the disk Di is associated with the processor Pi. It means that when we use a disk D1, it is associated with the processor P1. Then parallel sorting, then the range partitioning sort. We choose the processors P0 to Pm, where m is equals to n-1 for doing the sorting. Then we create a range partition vector with m entries and on the sorting attributes. Then we redistribute the relation using the range partitioning. All the tuples that lie in the ith range are sent to the processor P1, and the P1 stores the tuples and receives the data, and it receives temporarily on the disk D1. Then these steps requires the input, output, and communication overhead. Then each processor Pi sorts its partition of the relation locally. Each processor executes the same operation in the parallel with other processors without any interactions with the others, that is the data parallelism processing. Then finally we merge the operation, that is the trivial. Then parallel sort, parallel external sort merge. We assume the relation has already been partitioned among the disks D0 to Dn-1. Whatever be the manner, then each processor Pi locally sorts the data on the disk Dn. The sorted runs on each processor are then merged to get the final sorted output. Then we parallelize the merging of a sorted. The sorted partitions at each processor Pi are range partition across the processors P0 to Pn-1. Then each processor Pi performs a merge on the streams as they are received to get a single sorted run. The sorted runs on a processor's P0 to Pm are concentrated to get the final result. Then interoperator parallelism. Then pipeline parallelism. We are considering join of four relations, that is R1, R2, R3, R4. Then first we join the R1 and R2 and store the result in temp1. Then we join the temp1 and R3 and store the result in temp2. And then we join the temp2 and R4 and we just get the final result in the pipeline parallelism. Then we independent parallelism. Then we consider a join of four relations, that is R1, R2, R3, R4. Here we store the result R1, R2 join in the temp 1 and R3, R4 join in the temp 2. And thus we perform the join of a temp 1 and a temp 2. Here the P1 and P2 are worked independently in a parallel and P3 has to wait for the inputs from P1 to P2, P1 and P2. It doesn't need to provide a high degree of parallelism and useful with a lower degree of parallelism, and it is less useful in a highly parallel systems. Thank you.